Firms in some oligopolies collude. Collusion occurs when firms cooperate to achieve market outcomes that resemble what would occur in a monopoly. Such cooperation maximizes the total profit earned in the industry. Sometimes oligopolies that are colluding are called cartels. Some cartels sign formal agreements that state the quantities and prices for each seller. The members of OPEC, for example, meet periodically in Geneva to determine the prices they will charge and how much each country can sell. Cooperation with a formal agreement is called explicit collusion. Some oligopolies appear to cooperate without a formal agreement. Cooperation without a formal agreement is called implicit collusion. Well, if collusion maximizes total profits, why don't all firms collude? The reason is that collusion is difficult to implement and maintain because each individual firm usually gains if it cheats on the collusive agreement, while the other parties try to maintain it. As a result, many firms fail to maximize their total profit, and pricing is closer to the competitive level than what a monopoly would charge. In some cases, oligopolists charge the same price that competitive firms would charge. The history of OPEC provides many examples that illustrate the difficulty of maintaining an agreement. Many of the member countries usually produce more oil than they agreed to sell when they signed the agreement in Geneva. Saudi Arabia often kept the price of oil high by selling less than it agreed to sell. One reason that the price of oil has fallen recently is that Saudi Arabia is not reducing its output when the other countries cheat. Here's a simple example. Let's examine the oil industry when only two oil producers exist, Saudi Arabia and Russia. Further, let's make it really simple. The industry demand is a straight line that intercepts the vertical axis where price equals 100 and the horizontal axis where quantity equals 200 barrels per day. Average total cost is constant and equals $4 for any level of output. Since average total cost is constant, marginal cost is also constant and equals $4 for every barrel produced. Now let's find the monopoly let's find the monopoly price and quantity. If only one firm existed, it would maximize profit by producing 96 barrels of oil a day and charge a price of $50. The table below shows that the marginal revenue of the 96 barrel is $4.5 and the marginal revenue of the 97th barrel is $3.5. So the profit maximizing quantity occurs when you make 96. That gives us a price of 52 and the total profit is 4,608, which again is a little bit higher than the profits at quantity 95 or quantity 97. When two firms collude, they maximize the sum of their profits when the sum of their output equals 96. The only question is how to split the profits. Let's assume that the two firms collude and agree to split the market 50-50. In that case, each firm would produce 48 barrels per day. They would both charge a price of 52, and each would earn a profit of $2,304. They would simply divide the total profit equally. Now let's look at what would happen if Russia cheated on the collusive agreement while Saudi Arabia continues to produce 48 barrels a day. Again, the agreement is to make 48 a day. Well, what if Russia cheats and produces more? The table below shows what happens as Russia increases output QR from 48 to 51, while QSA, Saudi Arabia's output, is constant at 48. We see that Russia's profit increases because marginal revenue it receives from each initial barrel is greater than $4 the marginal cost. So here's quantity QR, here's from 48 to 49 to 50, 51. But Saudi Arabia is keeping their output constant at the agreed upon levels. The total quantity rises by 1. The price of the market decreases. Total revenue for Russia is going up. Marginal revenue is 28.5, 27.5, 26.5, 25.5. The marginal cost for Russia is only $4 a piece. That means that Russia's making more profit for each of these extra barrels of oil it's selling, and we can see that its profits rising from 2304 to 2371.5. Russia has an incentive to cheat. Turns out that Russia can maximize its profit by producing 72 barrels per day when Saudi Arabia produces 48. So we've got that. Here's if Russia makes 71, its profit's 2591. The marginal revenue is 5.5. If it produces 72, marginal revenue is 4.5. And if it produces 73, marginal revenue is 3.5. So 72 is the profit maximizing level of output for Russia if Saudi Arabia produces 48. Russia's maximum profit is 2592. Of course, Saudi Arabia is not going to be happy when Russia cheats. Saudi Arabia's profit decreases from 2,304 to 1,728 when Russia increases output from 48 to 72. We might expect Saudi Arabia to respond in kind. Let's suppose that Russia chooses to produce 72 barrels per day and that Saudi Arabia then responds by producing the output that maximizes its profit given Russia's choice. The table below shows that Saudi Arabia maximizes its profit by producing 60 barrels per day when Russia produces 72. So here's Russia with 72. Saudi Arabia goes from 59 to 60. The marginal revenue of the 60th barrel is 4.5. The marginal revenue of the 61st barrel is 3.5. 60 maximizes profit, and the maximum profit that Saudi Arabia can make is 1,800 when Russia produces 70 barrels of oil. We can identify what's called the Nash equilibrium by finding when the chain of responses ends. If Saudi Arabia produces 60 barrels per day, then Russia maximizes profit by producing 66 barrels per day. If Russia produces 66 barrels per day, then Saudi Arabia maximizes profit by producing 63 barrels per day. If Saudi Arabia produces 63 barrels per day, then Russia produces 64 barrels per day. If Russia produces 64 barrels per day, then Saudi Arabia maximizes profit by producing 64 barrels per day. And it's also true when Saudi Arabia makes 64, then Russia produces 64 barrels per day. We've reached an equilibrium. Neither firm has an incentive to increase or decrease their output when the other firm keeps its output constant when both firms produce 64. The Nash equilibrium is for each firm to produce 64 barrels per day because neither firm has an incentive to change its output when the other firm's output is 64. Let's just kind of double check it with two tables to follow up. So here's Russia, has output of 64. If Saudi Arabia produces 63 or 65, its profit goes down to 2,047.5. It's better off keeping its output at 64. If Saudi Arabia produces 64, Russia can make 63 or 65. Again, its profit goes down a little bit if it changes output. So neither country has an incentive to change its output from 64 when the other firm's output is 64. We have a Nash equilibrium. This analysis illustrates the tension faced by oligopolists. By colluding, each firm can earn $2,304. However, each can increase its profit by cheating if the other firm does not. But if both firms cheat, equilibrium occurs when each earns only $2,048. At this equilibrium, neither firm has an incentive to change its output, but both firms would benefit if both firms decrease their output. The magic trick is, or the million-dollar question is, how can the two firms coordinate their activities and both reduce output, even though individually each of them has an incentive to increase their output? You've got some explaining and understanding questions to do next. Go forth and conquer.